What's up, Math Club? Okay, so this is lesson three. We're going to look at subtraction with positive and negative integers. And this is going to be a brief video. I'm going to try to keep it under 10 minutes, okay? So if I have a number line, boop, boop, boop. I like this whiteboard so much better than our Promethean board. Maybe just because I'm used to it. If I have a number line and this is two, and it goes three, four, five, six, seven, eight, nine, 10, and this is 10. This is one here. I have a point here at 2 and I have a point here at 10. What is the distance between 2 and 10? To calculate that distance, and you may just be able to count 1, 2, 3, 4, 5, 6, 7, 8. Awesome. So we know it's equal to 8. Um, what do I need to do with 10 and 2 in order to arrive at 8? And you may say, well, that's a subtraction problem, Mike. And you would be correct. 10 minus 2 is equal to 8. Oftentimes, when we're dealing with distance, we find that subtraction is the operator. We talked about that in our last class that we go with. By which I mean we talked about what an operator was. So let me get rid of this guy and add some more lines here. Boom, 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 boom. Oh my gosh, um we've gone to the left of 0. So if I now say, well, what's the distance between 10 and -2? Well, we can do the same exercise. We can count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And is it still a subtraction problem? Because we would think, well, we would add 10 and 2, but we're not adding 10 and 2. We're adding 10 and -2. So our operator is subtraction, but now I am dealing with a -2, and the answer is 12. And that really confuses people to see all those negative signs as a subtraction sign and to have a bigger positive answer than either of the numbers that we have before us. But it is, in fact, true. That's how this works. I hope that's not too confusing. But it is. It's going to take you a while to wrestle with it. Um, and that's okay. You will develop fluency over time, I promise. But for now, I don't want you to think too much about subtraction when you see it in a problem. What I want you to think about is this rule. I'm going to type it out because it's so important. Subtraction means to add the opposite number to the right, the number to the right. Okay, so this is a subtraction sign. This is a +2. This is a subtraction sign. This is a -2. If subtraction means to add the opposite number, the number to the right of the subtraction sign, that means all I have to do to this is to say, I'm going to add the opposite number. The opposite of a positive number is the negative number that's the equal distance from 0. So the opposite of 2 is -2. The opposite of -2 is +2. So if subtraction means to add the opposite number, the number to the right of the subtraction sign, then 10 minus 2, which is 8, is 10 plus a -2, which is also 8. 10 minus -2 becomes 10 plus a +2, or +12. Okay, I'm going to show you a few more examples, and then that's going to be it. Sometimes people call this the bop-bop rule. I'll tell you why in a second. I'll show you why. How do I clear the board? Anyone have a thought? How about I just erase, 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 erase? I don't really love this method. I'm going to pause the recording. Okay. I did not find an efficient way to erase the whole board, but I wrote up some subtraction problems for you. So we're going to work on this thing. Even though we might know what 10 minus 8 is, we may know what many of these problems are. But we're just going to work on what we just called the bop bop rule, meaning I'm going to change all of these to addition problems and add the opposite number, the number to the right. So why do we call it the bop bop rule? Bop bop. Now it's an addition problem. Bop bop. Now it's an addition problem. This wasn't the case of when I was subtracting a positive number. This is what it looks like if I subtract a negative number. Bop bop. Bop, bop. That's a positive. Bop, bop. That was a negative, became a positive. And then these are problems that we did in the lesson before. So I won't go too much into depth about how to do these. But here are the answers just so that you can see. Okay. Now you might be thinking this is symbolic overload. We talked about that before. And it might be. You will develop a fluency with this, but you do have to practice. So please do as many of these problems in this lesson as you can. Okay? Okay. I will see you in a very brief second for me. It might be longer for you for lesson number 4.